Well, one of the most interesting things about right triangle trigonometry is that we've got a host of applications. Just about everywhere that you look, you can find some sort of right triangle problem that can be applied. And here's a good one. This is a tapered shaft. Sometimes these are used in engineering or different pieces of mechanical uh, things. And this tapered shaft has a diameter of 5 centimeters. And the shaft itself is 15 centimeters. Now I've kind of exaggerated what it would look like right here. But the taper itself is 3 degrees. That means that the outside of this shaft increases its diameter as we go. And while the internal area of the shaft just stays the same, right? Just as a nice right cylinder. So the question is, what is the diameter of this particular end of our tapered shaft? Well, in order to find out, what we're going to have to do is we're going to have to do a little bit of a calculation. In this case, our calculation involves this taper angle and this right triangle. And we might note that if the cylinder itself, if the shaft is 15 centimeters from top to bottom, that means 15 centimeters. We've actually got a, uh, a right triangle enclosed inside of the internal structure of this cylinder, right? We could actually write it this way. I'm going to exaggerate my 3-degree angle, but essentially it looks a little bit like this. We have this angle of 3 degrees enclosed in a right triangle, which we know that the adjacent side is 15 centimeters. We don't know the length of this side, nor do we know the length of this side, but the question is, this side right here, this is the one that we want to know, right? So I'm going to call that x, right? Because if I add that, right, I know I'm going to get x over here and a little bit of extra material x over here on this side. So 5 centimeters right here, this total length is going to be 5 centimeters plus 2x more centimeters, if you follow me. So here's what we do. This right triangle, we've got an adjacent side, we want an opposite side. We might ask what ratio relates opposite side and adjacent side. Well, that would be tangent. So we could say, well, if I took the tangent of that 3-degree angle, what should the ratio be equal to? Well, in this case, the opposite side, which we're calling x, and the adjacent side, which is 15 centimeters. So to find x, we're going to take 15 and we're going to multiply it by whatever we would get from the tangent of 3 degrees. Let's see what that works out to. I'm going to get my calculator out right here. And I'm going to take my 3-degree angle, take tangent of that. Then I'm going to multiply that result by 13. Divided by 15, right? It was 15 here. We get 0.786. I'll go ahead and carry out an extra digit right here, even though I'm going to give this to the nearest hundredth. So x for us is going to be 0.786 centimeters, right? But to find our diameter, we're going to have to take that 5 centimeters, which represents the length of the small internal end right here, and the 2 extra x's. So 2 times 0.786. So getting my calculator out right here, I'm going to multiply by 2. I'm going to add 5. And there it is, 6.572. So my diameter should be about 6. What do we say? There it is. 572, 6.57 centimeters. And that would be rounded to my nearest hundredth my answer to this question. And we're done.